We're going to talk about square root functions. We talked about these a little bit in our inequalities videos, but we're going to get the whole dad blasted thing this time. Okay, so without further ado, let's talk about the parent function, the square root parent. Is it interesting how all these functions have a single parent? What is even happening right there? That doesn't even make sense. Okay, so the square root parent function is exactly what you'd expect it to be. It's f of x equals the square root of x. Wow, freaking rocket science. What it looks like is this. Okay, so we've got a half a parabola. That's basically exactly what we're looking at. Okay, we're looking at a half a parabola. It starts at the origin, you go up 1 over 1, and then it just continues on. Yay, happy day, right? Whoa, yes. Okay, so that's what she looks like. Very, very good. Now, how do we translate the square root parent function? Well, it turns out that you translate it exactly the same way as a quadratic function or a linear function or pretty much any other function. Surprise, surprise. We've kind of heard this before. Okay, so you translate it with this equation. F of x equals a times the square root of x minus h plus k. All right, we've seen stuff just exactly like this before. Okay, so the a part is the dilation, right? We've talked about dilation, and in this context, what that just means is it gets bigger, so it gets wider if we have a bigger number, or if we're doing a fraction, it gets narrower. Okay, all that kind of stuff. Now, the h term is the horizontal translation. Okay, then k is the vertical translation. This is just like a parabola, just like a quadratic function. It all works exactly the same. It's that simple, folks. That is all there is to it. Let's look at some examples real quick. I'm going to put several of them up here, and then we're going to kind of look at the pictures of these. Actually, why don't I pop these up on the screen? I think that's going to be easier to see. So, easier to see. Haha, he said jokingly. When we look at these, all these pictures up here, let's see. So, this green one right here is the parent. Oh, I need something to write on, huh? This is the parent right here. This is y equals the square root of x. Easy peasy lemon squeezy. Now, this red one, you notice it starts at the exact same place. It is a dilation. This one happens to be y equals 2 times the square root of x. So you can see that it gets wider, quote unquote, than the parent. So you go up 2 over 1, and it kind of stretches from there. Makes sense so far? Yay, happiness. Now, a vertical translation is like this guy right here, this purple one. This one happens to be y equals the square root of x plus 2. Now, you'll remember from our discussion of quadratics that the vertical translation goes exactly the same way as you'd expect. So if it's plus 2, it goes up 2, and then from there it looks just like the parent. So it's the parent shifted up. If it were minus 2, it would go down. Now, finally, this orange one out here is a horizontal translation. Process of elimination, you could have guessed that one, right? So this one happens to be y equals the square root of x minus 2. You follow the difference. Okay, so now this one, just like with a quadratic, it goes the opposite way of what you'd expect. So if it's minus 2, it goes to the right. If it is plus, then it goes to the left. This makes a lot of sense. Sounds pretty good to me. All right. So let's delete that. Yes, I do. Let's look at another example. Okay. Let's look at an example with everything thrown in all together. So let's get a color that you can definitely see. Y equals 2 times the square root of x plus 1 plus 2. All right, so it has a vertical translation. So let's see if we can kind of chicken scratch this out. Let's see. I don't know if you're going to be able to see this. Yeah, that's probably fine. So it's going, let me erase what's going on here. All right, so first of all, it is going to get wider. It's going to go up bigger by 2. So it's going to, instead of, when we start at the beginning, instead of going up 1 over 1, we go up 2 over 1. I'm going to show you a better graph of this in a minute. So it gets wider. That's what this 2 right here does. Now this one is inside of the square root. And so this is going to be horizontal. This is going to be left and right. No problemo. Now, this one, it goes the opposite. So it's plus, so it actually goes to the left 1 space. All right? Now, outside here, this is the K. This is the up and down part. It goes exactly like what you'd expect. So this one is going to go up 2. So let's take a look at a prettier graph. Okay, so it does exactly like what we just said. It goes up 2. Oh, I need somewhere to write, huh? Let's get somewhere to write real quick. So it goes up 2. You see that? And then it goes back to the left 1. So we start right there. And that 2 in the front, we go up 2, over 1, and then you connect the dots. Beautiful. Makes sense? Sounds really, really good. Let's do one more thing, and then we're going to wrap this discussion up. Okay, so, yes, I do. Let's hide that, and let's erase all of these. Oops, that's fine. We want to erase all of... Whoa! We're having fun. Technical difficulties. Okay, so that looks about right. Thereabouts. We're probably back in the screen, and we're going to delete all the things. There we go. So we're going to do one more example. That's all right. This is a short video anyway. Calm down. Okay, so we're going to do one more example. This time we're going to do an inequality. Okay, so instead of equals, we're going to have greater than or less than. In this particular example, it's going to be y is less than the square root of x minus 2 and then plus 1. Okay, so there's no dilation, right? There's no dilation whatsoever, but there is a horizontal translation. So it goes to the right 2 spaces, and then it goes up 1 space. Follow what I'm saying? Okay, so when we graph this, we're going to have, I'll show you the real one in a minute. We're going to go to the right 2, up 1, so it's going to start somewhere about there-ish. And then it goes up just like the parent, so something like that. Now, what do we do with this? First of all, let's get our eraser out here and make it smaller. This should actually be dashed. Why should it be dashed? It should be dashed because there's no equal to. It's only less than. So we should have a dashed line. So let's fix that. Make it a dashed line. Yay, happy day. Very, very good. So now where are we going to shade? This is y is less than all this mess. So if it's less than, we shave underneath. So you're going to go and you're going to shade down here. It stops right there because the graph doesn't exist over to the left of that dot. And it just kind of shades in there. So let's look at a prettier one. so we can see what that'll look like. Because it looks pretty much like what I just drew. So there she is. So we started at right here, at over to the right 2 and up 1. Oops. Okay, so we started right there. And then we graphed it just like the parent. And we did a dashed line, and then we shaded. Beautiful. Absolutely fan-flipping-tastic. That's it for this video. In our next one, we're going to look at radical expressions and how to deal with them. So we're going to be still going to be looking at square roots and cube roots and fourth roots, but kind of more the algebra part instead of the graph part. Look forward to you hearing me then.